We are going on to chapter 10, and in chapter 10, we're going to be talking about hypothesis tests. We are going to start in section 1 with talking about what is a hypothesis test and the language that we use in a hypothesis test. We're going to learn about what a null and alternative hypothesis are, what our type 1 and type 2 errors are, and how to state our conclusions. So a hypothesis is a statement regarding a characteristic of one or more populations. We're going to look at a single population parameter in this chapter. In the next chapter, we'll go on and look at how we can compare multiple population parameters. So, for example, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. That's a hypothesis. The researcher is making a claim. According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. That's a claim. That's a hypothesis that the researcher is making, and then we'll need to follow that up with data to determine if their hypothesis is correct. Using an old manufacturing process, the standard deviation of the amount of wine put into a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. This is a hypothesis. It's a claim that the quality control manager is making, and then we'll need some data to follow that up and check and see if that claim is accurate or not. These are all examples of hypotheses. But caution, if we actually have population data, we don't need to do this. So this is called inferential statistics. We are inferring something about our population. In the last chapter, we looked at those confidence intervals where we were inferring what do we think the population proportion or the population mean might be based off of what our sample proportion or mean was. We had to infer. If we actually have the whole population data, then we don't need to go through any of this. So this is just a caution about that. We only use this if we are sampling a portion of the population. Hypothesis testing is a procedure that's based on sample evidence and probability. It's used to test statements regarding a characteristic of one or more populations. Here are our steps. The first thing we're going to do is we're going to make a statement regarding the nature of the population. We have to begin by saying, why are we doing this anyway, and what do we think the outcome will be? This is kind of like that scientific method that you've talked about in your science classes, or if you had to do a middle school science project or something. I've talked about mine with the socks before. You have to begin by making a hypothesis, a claim. What do you think is going to happen? What do you expect the outcome to be? So that's where we have to start. Then, after we've made our claim, and this is really important, you have to make the claim before you collect your data. You can't collect your data and then look at it and be like, it looks like this happened. Well, that's kind of like reading the last page of a book before you read the story. So you have to make your claim first. Then you collect your evidence, which is your sample data, to test that claim and see if that's true. Then you're going to analyze the data to make your conclusion. Our null hypothesis, which we denote H0 or H naught, H sub 0, is the statement that we're testing. It is a statement of no change, no effect, or no difference. And we assume this to be true until we have enough evidence to conclude otherwise. So we always have our null hypothesis being nothing has changed. That's always the starting assumption, is that we must begin with the premise, nothing changed, prove me wrong. So that's like the meme now, right? Like, change my mind. That's exactly what hypothesis testing is this is what I believe because this is the way it is. Change my mind. And that's what hypothesis testing is. So we have to begin with that null hypothesis of nothing's changed. The alternative hypothesis is what the researcher thinks the change is. So the researcher is always doing this testing because they believe something has changed. And so that's our alternative hypothesis that the researcher would then need to gather evidence to support that claim. So there's a few different ways that we can write that alternative hypothesis. So one type of hypothesis test is called a two-tailed test. The two-tailed test says that null hypothesis is the status quo. The parameter is some value. The proportion of the population is this. The mean of the population is this. It's our status quo. The alternative hypothesis, that H1, is that the parameter is then not that value. The researcher just thinks things are different than they used to be. The researcher's not making a claim in either direction, just to say things are different than they used to be. And this is called a two-tailed test because it's just saying it's not this. It could be bigger, it could be smaller, but I don't know, but I just don't think it is what it used to be. We could do a left-tailed test, and that is to say that the alternative hypothesis is now that the parameter is smaller than it used to be. Now it says some value and some value there, and both of those have to be the same value in a problem. So the null hypothesis is that the proportion or the mean or the standard deviation, whatever parameter we're testing, is equal to something. And that's our status quo. That's what previous tests have shown. Now, in this, our researcher is claiming that they believe that now that parameter is smaller than that same value. So where it says some value, they actually have to be the same value as each other within the problem. But this is to say that they believe that whatever it is we're measuring has decreased. And then on the other side, we can do a right-tailed test saying that now we believe that whatever we are measuring is now larger than it used to be. So, in other words, a null hypothesis is a statement of status quo or no difference and always contains a statement of equality. The null hypothesis is assumed to be true until we have enough evidence to the contrary. We seek evidence that supports the statement in the alternative hypothesis. So we always believe our null hypothesis is true until we have gathered enough information to change our minds. So here are a few examples. These are the same ones that we looked at the beginning, and now we want to say, are these going to be two-tailed? That means both sides, left or right, or another way of saying left or right is going to be a less than or a greater than alternative hypothesis. So in 2008, 62% of American adults volunteered their time for charity work. A researcher believes that this percentage is different. So what would our hypotheses be here? Our null hypothesis in this one is going to be that that parameter is still 62. So that our proportion of the population is still 0.62. That's our null hypothesis. Nothing has changed. The alternative hypothesis, because it says the researcher believes this is different, is going to be the not equals statement for a two-sided. The researcher isn't saying more or less Americans are volunteering their time, just that it's not 62 anymore. So this is a two-sided test. In the next one it said, according to the study, the mean length of a cellular telephone call was 3.25 minutes. The researcher believes now the mean length of a call has increased. So our null hypothesis is that the mean is 3.25. That's what the previous data showed, that's the status quo, and that's our null hypothesis is nothing has changed. The alternative hypothesis is the researcher believes the mean has increased, that the mean is now more than 3.25. So that would be a right-tailed test for a greater than statement. Then our standard deviation in a bottle of wine was 0.23 ounces. Quality control manager believes that has decreased. Our null is that sigma, the standard deviation, is 0.23 because that's what it used to be. That's the status quo. That's what we have to start our assumption as. Now we need to gather evidence to prove the alternative hypothesis, which is that our manager believes that the standard deviation is now less than that 0.23. So this is a left-tailed test. So there are 4 things that can happen in hypothesis testing. One thing that we can do is we can reject the null hypothesis when the alternative is correct. And that's a correct outcome. We say, you know what, that null hypothesis, you changed my mind. You've gathered enough evidence, you've changed my mind. I think now the alternative is correct, and it actually is correct. So go us, we made a good conclusion. We could not reject the null hypothesis when the null hypothesis is actually true. This decision would be correct. So we could say, you know what? This is the status quo, and you haven't given me enough to make me believe that things have really changed, so I'm going to stick with the null. And as it turns out, the null is actually right, so go us, we made a good decision. The third thing that could happen would be that we could reject the null hypothesis when the null hypothesis is actually true. So we could reject the null. That means to say, you know what, I do think the status quo has changed. You've given me enough evidence. I'm ready to change my mind. But then as it turns out, I really shouldn't have. I shouldn't have changed my mind. The null hypothesis is actually true. The status quo hasn't changed. This is what we call a type 1 error. Another way to think about a null and alternative hypothesis, and this will come up in a later slide, is to think about our legal system and the idea that you're innocent until proven guilty. So the null hypothesis is innocent. The alternative hypothesis is guilty. So in this case, we're rejecting the null. So we're rejecting the idea that somebody is innocent and claiming then that they are guilty when they were actually innocent. So we're sending an innocent person to jail with a type 1 error. The fourth thing that could happen is we could not reject the null hypothesis when the alternative was actually true. So we could say, you know what, I'm not ready to change my mind. I'm not going to believe that the status quo has changed, but in reality it actually had changed. So going back to our legal idea here, this would be if we do not reject the null. Remember, the null is the idea of innocent until proven guilty. So we're not rejecting that idea. We're saying, okay, not guilty, but they actually were. So in this error, we're letting a guilty person walk free. This is called a type 2 error. So here's a couple of examples. What would it mean to make a type 1 or a type 2 error in these? So in that volunteering problem, if a researcher believes that the percentage is different today, a type 1 error would be that the researcher concludes that the proportion is not 62 anymore, but in reality, it actually is. The type 2 would be to say that the proportion is still 62, nothing's changed, but it actually has changed. And then that's just kind of the same idea there. So our type 1 error, we call alpha the probability of making a type 1 error. And then the flip side of that, beta, is what we call the probability of making a type 2 error. So type 1 probability is what we call alpha, and that's going to be an important measurement for us, our alpha level. So this lines up with our level of significance. So when we learned about those intervals, those confidence intervals, where we said this is what our sample measurement is, but we're going to give ourselves that margin of error, we were confident at a certain percentage level. 90, 95, 99 are our common levels. Alpha lines up with that, except that it is the flip side of that. I thought it was on one of the next slides. But so if we would have a 95% confidence interval, our alpha level would be 0.5. So it's the flip side of that. And it's the probability of making a type 1 error. So as the probability of making a type 1 error increases, the probability of making a type 2 error decreases. They kind of balance each other out that way. And then this is a language thing, and it's very particular and it's very picky. We never accept a null hypothesis without having access to the whole population data. Rather, we say we do not reject the null. Okay, so we never accept the null. we say that we do not reject the null. Again, like our court system, we never declare somebody innocent, we declare them not guilty. Okay? We don't know if they're actually innocent. We hope that the court system worked out right and that all the lawyers did their job and that we didn't make an error here. But because we can't actually know for 100% fact that somebody's innocent, we can only say that there's not enough evidence to say they are guilty. Okay? So we never accept the null. We only say we do not reject the null. Okay, so according to the study, the mean length on a phone call was 3.25 minutes. The researcher believes that the mean length has increased since then. So we're going to suppose that our sample evidence indicates that the null hypothesis should be rejected. If the null hypothesis should be rejected, we would say that the statement in the alternative hypothesis is that the mean length is greater than 3.25 minutes, and we are going to reject the null, saying there is sufficient evidence to conclude that the mean length of a phone call has increased or is greater than 3.25 minutes. Here we would reject the null because we have gained the evidence to say that the mean is greater than 3.25 minutes. Suppose that our evidence indicates that the null should not be rejected. We are going to say the null hypothesis is not rejected. We're not going to say we accept the null. We're just going to say we don't reject it because there's insufficient evidence to conclude that the mean length of time is greater than 3.25 minutes. Okay? So we're just going to say, you haven't given me enough to change my mind, so I'm not rejecting my null hypothesis. And that is the end of our first section. So in our next video, we'll go on to 10.2 and we'll look at now how to actually do this hypothesis testing for a population proportion. All right, so I'll see you real soon for that lesson. As always, ask me whatever questions you have.